Hi everyone! Today I'll be presenting a project that I've been working on over the past year, and I will hopefully be able to teach you a bit about manipulating images. The project is called ppmp, which stands for Primitive PNG Manipulation Program. It currently only works on Linux with X11. There is a version for Wayland, but it isn't fully featured compared to the X11 version. If you want to run it yourself, take caution as there are a lot of memory issues and bugs. You'll find the GitHub link in the description. So, without further ado, let's get into it. I'd like to start with the scaling of images. I've implemented two different scaling methods, box sample and bilinear interpolation. Of course, there are more methods, for example, bicubic interpolation, or you could use an AI model. Anyways, box sample is the simplest possible scaling method. You simply spread out the pixels, and when there are gaps, you just fill them in with the value of the next closest pixel. As you might be able to imagine, this leads to a quite blocky result. Bilinear interpolation is a bit more complicated. We still need to spread out the pixels, but we then take a look at the closest 2 or 4 pixels and choose a value that is in between them. If we imagine a black and white image as a field of cubes, where the brightness correlates with the height of said cubes, it becomes a bit easier to imagine. For colored images, you'd have to think in 4D, and that's a bit too hard. There are actually two ways to rotate an image. One is very math heavy, and the other one just shifts pixels around. Rotating with skews is a slightly obscure way to rotate an image. If you want to learn more about it, I can recommend a YouTube video by Matt Parker from Stand Up Maths. The link is in the description. Now, there are actually several advantages to this method. When rotating an image with a so-called rotation matrix, the second way to rotate an image, pixels might not align with the pixel grid, and you can get gaps and overlapping pixels. This will become clear later. When rotating with skews, you're just shifting the pixels along the X and Y axis and won't run into this issue. Another benefit is that it is easier to implement. So, rotating with a rotation matrix. Now, don't get scared, it isn't as complicated as it sounds. All we are doing is taking the X and Y coordinates and applying a so-called rotation matrix to get the new position. We then round the position to the nearest integer and fill any holes by interpolating between the surrounding pixels. This method can result in a loss of detail and is generally not recommendable for rotating pixel art. Image convolution is a very important topic. You can get some crazy results with it, and it is the main component in both blurring and edge detection. I'll be explaining it using a box sample blur as an example. First, we need a kernel. A kernel is just a grid of numbers. In the case of a box sample blur, the numbers are 1 over the area of the grid. So for a 3x3 grid, you'd get 0.111. Now we simply place our grid on the image, and every pixel within it gets multiplied with its corresponding number, and everything gets summed up. This will be the new value of the pixel. Remaining on the topic of blurring, my personal favorite is the Gaussian blur. In this case, The kernel gets its value from a 3D Gaussian distribution. This makes the image very smooth and you don't get the blockiness of a box sample blur. Image convolution can also be performed with multiple kernels. This is the case for a lot of edge detection methods. For example, Sobel edge detection uses these kernels. After convoluting the two kernels and the image, we sum up the results and take the square root. Color spaces are very important and powerful in image editing. It allows the user to change the look and feel of a photo. You're all probably familiar with RGB, red, green, and blue. This is the most common color space, partially because literally every display uses it. Another very common one is HSV. It stands for hue, saturation, and value. Here is the formula for the conversion from RGB to HSV. This is extremely unhelpful and confusing. It is a lot easier to imagine the color spaces as 3D geometry. In that case, RGB would represent a cube, where R, G, and B are the X, Y, and Z axes. HSV, on the other hand, would be a cylinder. Saturation represents the distance from the center, hue would be the angle, and value the height. Now what we're trying to do becomes much clearer. We're basically morphing a cube into a cylinder. My favorite color space is OK Lab. It accounts for the fact that our eyes perceive some colors brighter than others, and I just find that very cool and interesting. The last topic I'll be covering is AI. I did not integrate any AI capabilities into my program, but it is a topic that has gained relevance over the past years and is thus deserving of a mention. Before we start, it is important to mention that the creation of AI models is at best ethically dubious and at worst outright theft. It is also important to note that you shouldn't use AI to make material that could damage the image of a person, nor use it to replace creatives. Now that that is out of the way, if you want to use an AI, I'd recommend Comfy UI. It is extremely flexible and easy to use. The link to it will be in the description. Here is an example workflow I used to turn myself into an anime woman. The reason behind the many notes is that I was trying to preserve as much of myself as possible. In my opinion, I succeeded, though you wouldn't be able to spot me in a crowd using it as a reference. There are, however, more than just ethical problems with AI. As you can see, there are a lot of artifacts. The eyes do not entirely make sense, and the ear and my hair are fighting with each other. So, despite the messaging from oh so many companies, AI will never be the final solution. To properly edit an image, you have to use a range of methods and maybe use AI to smooth over the errors. I hope you learned something, and goodbye. And no, I am not an AI-generated voice that came along with the AI woman I turned myself into. I'm just a completely different person entirely.